Hi everyone, welcome to the second video on partial fraction decomposition for Math 1452 at Texas Tech University, which is Calculus 2. So in the first video on partial fraction decomposition, we talked about what that was, i.e. decomposing fractions into different parts that are being added and subtracted together, and the four different setups we could have to decompose that fraction based on how our denominator factors. So our denominator could factor into linear or quadratic terms that are either distinct or repeated, meaning they have a higher power. So we talked about the setup for those four cases. So what we're going to do in this video is take a closer look at example 1 and 2, the examples that use linear terms, and look at how to solve for A, B, and C. So to solve for A, B, and C, we're going to use a strategy from algebra called solving a system of equations. So this phrase may be familiar to you. You may have heard it in a previous algebra class. In most high schools in Texas, we learned this in Algebra 2. So to solve this system, we're actually going to use a slightly different strategy than we would have used in high school. Because in high school, most of the time we're solving for x, but here we're solving for a, b, and c, and we're going to use x instead of solve for it. So let's just rewrite our setup that we had from the last video about decomposing this fraction in example 1. So I'm going to need a lot of space here to write, so I'm going to kind of go out into this left-hand margin. So remember that when we had these linear terms, we had a constant on top that we're going to solve for. So our first step in solving this system is going to be multiplying both sides of this equation by that denominator, x minus 2, x minus 3. And we're going to do the same thing over here. So what's going to happen is on our left-hand side, that entire denominator is going to cancel out. And we're just going to be left with a 1. And then on my right-hand side, that denominator is going to distribute to each of my fractions that I am adding together. So on my, let me just make this clear, these are fractions. So for my first term, the a over x minus 2, the x minus 2's are going to cancel out, and I'm just going to be left with a times x minus 3. And in my second term, my x minus 3's are going to cancel out, and I'm just going to be left with b times x minus 2. So what we're going to do now are we're going to, like I mentioned earlier, plug in strategic values of x. In particular, we're going to plug in the values of x that make that initial denominator 0. So remember that initial denominator is going to be x minus 2 times x minus 3. So we're going to start off by plugging in the value x equals 2. So whenever we plug in the value x equals 2, our new equation is going to be 1 equals a times 2 minus 3 plus b times 2 minus 2. And so remember we picked this so that x minus 2 is now equal to 0. And we know that anything times 0 is 0. So we just have the equation that 1 equals negative a because 2 minus 3 is negative 1. So that means that negative 1 equals a. So plugging in x equals 2 got rid of our b term and let us solve for a. And now we can plug in x equals 3 because that will make the a term cancel out and let us solve for b. So when we plug in x equals 3, we get the equation 1 equals a times 3 minus 3 plus b times 3 minus 2. And again, this 3 minus 3 becomes 0, and anything times 0 is 0. So we just get the equation 1 equals b, because this is b times 1, because 3 minus 2 is 1. So we can, now we have solved for a and b, so we can rewrite our initial fraction. So 1 over x minus 2 times x minus 3 equals, remember our a is negative 1, plus our b is positive 1. So now, remember, our goal was to integrate this. So we are integrating now this sum of two fractions. And these fractions are set up in a way such that each of them can be integrated using u substitution, where u is the denominator, and then we're going to end up with a natural log. So I'm not going to show the steps of integration for any of these questions. So just remember that these are solved by u substitution, where our u was our linear term that was in our. Okay, so next let's go to example 2. So again, we're just going to initially rewrite the setup of this integral. We have x plus 1 times x plus 2 squared, all under x. And remember that our setup, we had our linear term x plus 1 with an a on top, and our linear term x plus 2 with a b on top. So we need a third fraction that accounts for, we have two copies of that x plus 2. So again, our first step here is, just like before, going to be multiplying both sides of this equation by that full denominator. And again, we're doing that on both sides of our equation. On our left-hand side, just like before, that entire denominator is going to cancel out. So we're just going to be left with an x. And again, just like before, that denominator that we multiply is going to distribute to each one of our fractions that we're adding together. And we're going to have some cancellation. So in that first fraction, a over x plus 1, the x plus 1s are going to cancel out, and we're going to be left with x plus 2 squared. For our next fraction, one of the x plus 2s is going to cancel out, so we're going to be left with x plus 1 and x plus 2. And in our last term, both of the x plus 2s are going to cancel out, so we're just going to be left with x plus 1. Okay, so at this point, we can again plug in those strategic values of x that make that denominator 0. So let's start off by plugging in -2. So whenever we plug in -2, our equation is going to become, now here I want to point out here, now we have to plug in x equals -2 on our left-hand side as well, which we didn't have to do for our first example. So now our equation is going to be -2 equals a times 0, because when we plug in -2, that becomes x plus 2 becomes 0, plus b times -1 times 0, because -2 is -1, and -2 plus 2 is 0, and then plus c times -1. So we see that those first two terms are going to cancel. So we're just going to have that -2 equals -c, and dividing both sides by -1 lets us solve this. Next, we're going to plug in x equals -1. So again, our equation is going to become -1 equals a times 1 squared, because -1 plus 2 is +1, plus b times 0 times 1, because -1 plus 1 is 0, and because -1 plus 2 is 1, and then that c is just going to be multiplied by 0. So now we're going to have that those last two terms cancel, and whenever we square 1 and multiply that by anything, we're just going to get that same thing. So we have -1 equals a. Oops, sorry about that. So -1 equals a. So this allowed us to solve for a. So now we have exhausted the strategic values of x that make that denominator 0. So what we can do is we can use the fact that c equals 2 and a equals -1 and pick some other value of x to plug in. And it's not going to matter what that value of x is. So I like to plug in 0, because 0 means that things will surely simplify and become a little bit easier to work with. So what I'm going to do is plug in x equals 0, but I'm also going to plug in 2 equals c and -1 equals a. So again, remember that we're plugging things into this initial equation up here. I'm going to draw arrows to it just so we don't forget we're plugging things in. to this initial equation up here. So my equation becomes 0 equals, now a is -1 times 2 squared, because 0 plus 2 is 2. And then my b is what we're solving for. My x plus 1 is 1. My x plus 2 is 2. My c is equal to 2, and x plus 1 is 1. So we can multiply all of this out. So 0 is going to be -4 plus 2b plus 2. So 0 is going to equal 2b minus 2. I can add 2 to both sides, so 2 equals 2b. And finally, dividing by 2 tells me no. So I have now, let me kind of box these in just to make it clear where these are. I have now solved for a, b, and c. So just like before, I can rewrite my initial fraction as -1 over x plus 1 plus 1 over x plus 2 plus 2 over x plus 2 squared. So again, remember that our goal here is to integrate. So we can see that those first two terms, the -1 over x plus 1 and the 1 over x plus 2, are going to be integrated using u substitution to get us back to the log. And that third term is actually also going to be solved using u substitution, where u equals x plus 2. And then to integrate this, we're just going to use the reverse power rule, where we add 1 to the power and then divide by that. So we have transformed this into something that's easy to integrate. And again, I'm not going to show that integration. So this is our strategy of how we can solve for a, b, and c when we're using those linear terms. So in the next video, we will talk about how to solve that system whenever we're using quadratic terms, because those powers are a little bit more complicated. So that is going to be it for this video.